Hello everybody. So hopefully you guys can hear me. Alright, let's see. Okay, so let us start. I'm going to go over more about data types in Java. Then I will move to classes. Following that, I will do some inheritance, and then multiple inheritance with interfaces. I know I said before that in Java you can do multiple inheritance. You can, but is a lot different to what you will normally expect if you were to write some code that had multiple that had a one class inheriting or instantiating multiple things from different classes. In C++, in Java, it's slightly different. Actually, it's a lot different, to be quite honest. So I will show you that. And after that, I think I will probably go over some more things next week, and we'll call it a day, because that's basically everything you need in order to work on your EVM project. And the nice thing about the little, I guess, information that you will need, or that you will be needing, is that we use Java 5, I believe, for the EVM, or Java 6. I can't remember which version. It's one of the oldest. So we don't use all the fancy features that they added a few years ago, to starting from like Java 7 and above. So yeah. Anyways, so we're talking about, let me see if I can open up IntelliJ, because if I do Eclipse, I will have to change the settings for the terminal, and I don't feel like I want to do that. Alright, so hopefully you guys can see this. Oh, this is an example from before. So we'll just erase all this nonsense here. There you go. Let me just change that back to that. Once again, if you're watching, if you have any questions, feel free to ask. Alright, so oh my god, every time I have to do an update. Okay. The newer version will be just fine, and take into account that you will be more or less, many of the stuff that you will be using for any of the phases, for example for phase 1, all the fields that we declare, they go back to one of the earliest, not the earliest, but prior to Java 7, right? Now if you want to add fancy features that come in or that were added after Java 7, for example, or 6 or 5, then you will know whether you could do that when you build your project, because you will get an error, and you will get like a message that says this version of Java does not support this and that, for instance. So you will have to probably go back to one of the earliest, by the earliest I mean like prior to Java 7. But other than that, for the most part that I remember and that I know of, many students, or actually just to keep things simple, For as long as I've been teaching the class, I haven't encountered any issues from any of the students regarding the things that they couldn't do because they were using a newer version of Java. So yeah, and obviously, when you work on the faces, you could do whatever you want in terms of you could allocate you can use as many variables as you want to. You could use your own set of classes if you want to add them, which I wouldn't recommend because the way we have to build the XML file, it takes care of how to link all the class files and the like. So I wouldn't go as far as to say feel free to use your own utility classes. Don't do that, but what you could always do is just create your own functions within the classes if that's what you want. I had students ask me before, hey, can I create some helper functions? Will you take points off? And I said, no, feel free to do that. That's okay. All right. But yeah, so nonetheless, just if you encounter any problem, just let me know. And I would like to point this out too, if when you work on the faces, whichever face number you're working on, and if you build you can feel free to build your own test files. You will have to test your program, obviously. I will make available some of my own, but if you want to come up with your own and you want to share that, please let me know. And assuming that you want to know whether your implementation is correct, and you want to make your test file available, which in that case that wouldn't be considered cheating, since it's just a test file that everybody can use to run and see if the output that each of you generate is basically the same. So, but still, let me know, and I will make that available maybe on Canvas so that everybody can download it. All right. Did I answer your question? Any other question that you may have? Okay, well, I will. Okay, cool, awesome. Okay, so let's go back to all of this. So I briefly talk about the way in which you are supposed to create your classes in Java, right? The fact that you have some type of hierarchy that basically allows you to access things a lot differently to what you are used to if you were to write programs in C++ or C. So just keep that in mind. And if you haven't had the chance to watch the previous video, please go ahead and do it. Still, I believe it's still on Twitch. Anyways, so we're gonna talk about classes. And notice that here I have a class called Union. I was just creating an example. But what I'm gonna do is, in case you guys want to use IntelliJ, let me just excuse me. Let me see if I can just close the project. Great, so I'm going to close the project. What I'm going to do is I'm going to create a new one. Create a new project here. And the default that I have is Java 1.8. I'm not that hardcore to go to the newest. Besides, you have to install the JDK anyways. I don't know if I have, let me see, I can probably see if I have the Java-version. Oh, I have Java 14, I suppose, so I guess I could easily just go ahead and use that one instead. So I'm going to do Java, click on Next, create a project from template. I don't have a template to specify. You could come up with your own if you want to. And then I will just call it CS326. And I will change the location so I know when to remove it. Let's see, I will just put that on here. In a Java session. That will be the name of the project. Open. And then click on Finish. And so you're gonna see this. I don't know about Windows. I doubt you will see these windows right here. This window popping up. In terms of Mac, you shouldn't. The only reason why that happens to me, in case you're wondering, is because I like to have things encrypted. And so most of the stuff that I have is encrypted. Besides, once again, if you go back to the same folder, you could see here that it says Ben Sporn, which my uncle basically encrypted. the name that is, so I can't really decrypt it. But yeah, so don't worry about it. You shouldn't have this issue. And if you do, just click on OK, and there you go. So that's exactly what we have. We have an empty environment that has absolutely no files, and obviously the only thing that you have as part of your project will be just the standard library that comes with Java. So what I can do is I could add a new file. Let's say file, and I can call it I don't know. Let's call it main, just for fun. Uppercase later, main. Hold on. They change these things. There you go. Test script. Interesting. Okay, they changed that. Oh, not exactly. What happened? Well, let me just close this. I don't know what went wrong. I think it took into account. Let me see. Next. Project location. I want to put that here. Oh, okay. See, this is actually engineering at its best, I suppose. Let me try this one more time. Open. Finish. The project file is already exists. Idea. Okay, so let's go to desktop here. No. Previous. Let me just cancel this. I don't understand why this isn't working. And demo 234. Finish. Okay, so I don't know what the location of that is. I will probably let's see. What is the default? ls idea projects IOTA test union that test. That's the one too. Oh, okay, so it went to the desktop. What was the other one that I call? Let's see, file. Okay. Let's see. I don't know where the other project went. I'll have to look it up. Okay. Alright, well, too bad. Let's go to new, and then now it's gonna let me do the Java class, so I can call that main. And there you go. Cool. So hopefully that you guys can see that. I guess the problem that I had before was the fact that I manually changed the location of where the project was supposed to be stored or saved to. I haven't used IntelliJ in a while now, so maybe the settings that I specify initially contradict to what I was trying to do manually. Anyways, well, so we have the main class here. So I haven't done any import yet. What I'm gonna do is, as I said before, you need the entry point for your program to be executed, right? In the case of C++ or C, you use a main function. In Java, what we're gonna do is we're going to wrap the main function inside a class. But in order for the for the GVM to execute the main function, we need to make sure that the access modifier of the function is, for one, public, and second of all, is static, right? It's public because we want to be able to access it from within the class itself, and second, because it needs to be static. The reason for that is we don't have to create an object of type main in order to invoke the function main as well, right? So we're gonna do public static void main, and then we're going to pass on arguments to it, and there you go. And let me see if this works. If I do println the hello world, the typical suspect, and if I can spell, there you go. And if I build that, it's gonna take some time right now. Let me see the terminal here. Okay, cool. So that built perfectly fine. Now the question is, can I run it? So we can go to run main function, and we could see down below that it says hello world, right? So I have the environment ready. Everything seems to be working perfectly fine. And yes, I haven't included or haven't made any imports, or I haven't specified any imports here. And we will do that as we go. So don't worry, you will see that as I continue working on this. So anyways, we were talking about classes, right? And I did a little bit of a function, I think, an introduction to a function before in one of the earliest videos. So the idea that I have right now, at least for this one session, which is going to be very short, I'm planning on just talking about classes, like I said before, but show you the main difference between C++ and Java in terms of how you will sorry for all these phone calls. You will create a class, right? So now I have a class specified that is the main function, and the nice thing is I could instantiate an object of that class, right? Do something like main, let's call it temp, and do new main, right? Something like this, and then use the main, the temp, to call the main function, and I'm gonna pass basically no arguments to it. So this is like recursion right now, right? This is like the movie Inception, or if you like to call it the Matrix. So what do you guys think is gonna happen? Two things can happen. For one, it could actually make the call a number of times, which means that at some point we're gonna run out of stack and our program will crash. Or second, it will actually terminate successfully. It will, if I were to comment this out, something like this, for example, so it may terminate successfully. We will be able to see the message hello world. So we'll see. Let's see if it builds. So it built. It says at the bottom here, it says it built successfully. So there are no error messages whatsoever. And you guys know this. If it builds, I mean it must work, and it must work all the time, right? So let's run it. Let's see if it crashes. And look at that, it crashed, right? Eventually, we end up running out of stack. And since you guys will be working on the EVN, you will see as you get as we get closer to activation records throughout the semester, which is phase 3, if I'm not mistaken, you will understand why this happens. But for now, I just want you to know that the silly thing that I did here is, although I have the main function, the entry point, or the client code right here, defined in a class, I was able to create an object of the class that wraps the main function with it, and then make a call to it indirectly, right? So yeah, so obviously you're making multiple calls to the same main function a number of times, and eventually it's gonna crash, which is exactly what happens. Now, what we could do is, much like in C++, you have things that could be declared private, protected, and public. And by things, I'm talking about either fields, which they could be variables, or functions, methods in the sense of Java. So we could do public int a is equal to, for example, 4. We could do public float b is equal to 4.2f. We could do private string s equals Ben, right? We could do something like that. And now what's going to happen is, if we were to create an object, we actually, not necessarily, but if we want to access those fields, we'll have to create an instance of the main class in order to access every single one of them. These two fields right here, we could access them directly from the very simple fact that the access modifier, and this is very important, is declared public as opposed to just being private, right? In the sense of C++, normally you have the access modifier first, and then you have what we call the fields declared after, right? You have a list of fields that come after the declaration of the access modifier. And then if you want to make then, for example, you could have field 1, you could have field 2, and then if you want to make any other field private, you will do the same thing. You will specify the access modifier, this being private, and then right following the specification, you will declare all the fields that you want to be private. In Java, that's not the case. Notice that I could do what I do is I prepend the access modifier before before the type, right? Just like I did here. So we have that, and the cool thing is, you will learn this eventually when you take compilers, is that we could declare, for example, we could declare the fields anywhere in the main within the class, right? They could come before or after, it doesn't really matter. The reason for that is there is something called a second pass, and what happens is that with the first pass you want to make sure that things you want to find the location of things, and by things we're talking about fields and functions. And on the second pass, what we want to do is we want to be able to reference the things that we found when we did the first pass. And don't worry about that. The reason why I say this is, in certain languages, particularly in C++ or C, if you remember in C++, when you were first introduced to functions, they always told you to write the function first before the main, right? So for example, if you wanted to do a function that prints some statements based on whatever arguments you pass to it, you could do public, obviously assuming the notation for C++ will be more or less void, print, and then some args for arguments here, right? And then you will do the CA statement, and then you will print the arguments here, correct? So in terms of Java, what you will do is, if you want the function to be accessible without the need for an object, then you will make that static, right? So you will do a static, you will do print, and then you will pass whatever arguments to it. So let's just say we pass a string, and then we do the system.out.println, and then we do str, right? So now I have to put the void, which is the type of the function. Then what I do now is, in my client code, here in the main function, I could just easily access the function by calling it print, and then I do my name, for example. I could do basically hello, something like this, right? And then I do that, and then if I build it, so it built successfully. Notice that this hasn't cleared out or been clear. So now I'm gonna run it, and there you go. You see that it says hello Ben, correct? So that's actually one of the things that you do, and this is typically what they tell you in C++, that you have to always, or at least when you were first introduced to functions back in 135, they said, well, you have to write the function definition before the main function itself, right? For Java, you could put this below and notice that it will work perfectly fine. The main difference between Java and C++ in that sense, or at least back then, was that notice that because of the second pass, remember you have two passes, where the first pass is in charge of finding things, and on the second pass, the things that you found during the first pass, the second pass, you want to make sure that you can access it. That's the reason why in the first pass that we did here using Java, we know that there is a function called print that was defined after the main function. So on the second pass, when we try to trying to find whether or not this function can be used, then we know that from the first pass that it was defined within the same class body here, right? In case of C or C++, that's not the case. You have something that is called a single pass, which means that things have to be in a way forward declare. So you have to basically define things before the main function. Now you may be wondering, what about header files? Exactly, right? With header files, it's different. Typically, what they tell you is you have to define the function prototype, and the function prototype is nothing but the function signature, right, or the signature of the function, that consists of a return type, the name of the function, as well as whatever list of parameters the function takes, right, and then followed by a semicolon. So, for example, if you don't remember what a prototype is, this is the entire function definition, or what we refer to as the function declaration, right? If you want to do a function prototype or just write the function signature, what you do is you do the type, the name of the function, and whatever arguments it takes, followed by the semicolon, correct? And then if you want to write the function, if you want to write the body of the function, then what you normally do is you will put that after the main function, right? And you will do it like this. And so in C++ or C, when you were to compile your program, what happens is at least we know that there is a way for the compiler, in this case, right, to know exactly what type, what the return type of the print function is and what type of arguments or parameters it may take. It's not until you start linking things together and you make the invocation of the print function when it goes to the actual location of that function, to execute whatever statements you have defined within the body of the function itself. And so this is necessary, and that's the thing that you will normally do in header files too, right? For example, when you have, let me see if I can write this in here, just to give you that idea. So in C++, for example, right, in C++, you will have something that is called, you have your header file, and then you have, which is also referred to as, you could call it, well, let's do, or the interface, right? And then you have what is called, that's the header file, which is, what is that one in C++, is .h. Right, you have the .h, that's the extension of the file, that's the header file. Then you have your CPP file, which is the implementation file. Which is, the extension is .cpp, right? And notice that one is called an interface and the other one is called an implementation. Typically, the implementation contains the definition of everything that is associated with the header file, right? And typically, the interface, there is a reason why if you have programming in C# or Java, there are things that is called an interface. There is and the reason for that is because the interface typically contains functions, the prototype of a function, or in this case, it contains just the signature of a function. Whereas the implementation file will consist of the function, the signature of the function, plus the definition, meaning you write exactly the specifications, or in this case, the set of things that the function should do when it is called, right? And so you have your main file here now. So this is your interface, and then you have your .cpp, and this is the client code where the main function is. And then here you do a bunch of includes, right? You do like an include, and then you include, basically all that you include is the header file, right? You don't include the implementation, only the header file. So you have all of this general process here, right? That you will normally do. Quick question for those that are watching: why is that we do not include the implementation file in our client code? If you guys remember these from 135 and 202. Any ideas as to why is that they tell you to include the header file and now the .cpp? I never thought of that. Anyone else who might be watching? It's because of multiple. Not necessarily. Global variables. Well, you're saying something with the class. Okay, but let me ask you this. What if all you have in your header file is bunch of functions? And just functions, not a class, just all functions definitions. Could you give like four possibilities for choices? Well, okay, I will give you a hint. It has to do something with the preprocessor. Too many includes. No. I just give you I just give you the hint with the preprocessor. These are two type of libraries. What do you mean by that? Yeah, you're more or less on the right track. So it has to so without taking into account classes and just to keep things simple and easy, and just having a header file that contains bunch of function prototypes, and then we have a CPP file that contains the definition of every single function that we specify in the header file. So the main reason why, now you could still do it and that's not illegal, meaning that you could easily just go ahead and say include ben.cpp, and that will work perfectly fine. The main difference between doing an include ben.h as opposed to include ben.cpp is that with the .h file, right, what you do is you make sure that all the functions in this goes also, or this works also with classes, right, that all the functions that you declare are only assembled once. So for every other file, and this goes back to now the CPP file that uses the header file, remember we only have one instance of a function, which we can reuse as many times as we want to make the invocation, or in this case, excuse me, to find the function in the CPP. For example, what I'm saying is here, so let's just say that you have another function, another file here, right? And so let's just say that let me just change this. So this includes this guy. This also, for example, actually just to make this includes this guy, right? And have another include here. Right, and then finally we have one last one here where we do another include, and then this one includes this guy here. So what happens? So let's just say, so look at it this way, right? Let's see, in other words, if CPP everything. In a way, you are on the right track. And yes, so for example, back to this whole idea. So what happens when we just include the .h here, right? So let's just say that we have multiple functions specified here, and by the specification, I'm talking about just the functions prototypes, and the definitions of every single function here lives within the CPP file, right? So what happens? Notice that, let's just say that this is the client code now, right? So this is where the main function is. Exactly right here. That's where the main function is located. So what happens when we call? The main from within this file? Well, what's going to happen is now everything that was included or that was specified within this included statement will get actually copied into this file right here, right? So every single thing that was part of this file will get copied eventually down here. And then everything that is included here, right, will come directly from this file, will be copied also within this file, and so forth. So you see all these patterns, right? And so what happens if rather than using this, rather than using the .h file, instead we use the .cpp? Well, what's going to happen is you're going to create multiple declarations for the same function. The nice thing about just doing the .h file is that since we take advantage of the preprocessor, everything that was already assembled, meaning included, will not be included a second time. So for example, in this case, all the stuff that is included here will come here, right? All the stuff that was already included here will be part of this one by default, but we're only gonna grab exactly what we need, meaning only the things that are part of this file and that didn't come from this one, because everything here was already defined, or not defined, but rather assembled here directly. And we're going to start doing the same thing until we go back to the main function itself, right? Now, if you were to include the .cpp file, what's going to happen is all the functions that you're going to find in the source file right here will be copied here. And then when we include this file, then what we're going to do is we're going to recopy every single function that came from this file directly. And finally, when we find this include that comes from this file here, we're going to do the same number of copies for the same functions that were part of this file, right? So how many copies of those functions you will have? Well, you will have multiple ones on every single one of them, right? So clearly, it's much faster to just rely on the header file, because you will have only one copy, meaning that there will be all the functions that were specified here will be assembled once, and only once for every other file that includes this header file. Right? And the nice thing is, think about it this way, because you could also have another include here, and then this include right here could include also this file, and this include could include this file here. So notice that now you're including two different files where one includes already this one. So you have this pattern right here, right? So let's just say that rather than using the header file, you use the CPP, then you're going to end up more or less rewriting the same function that you included maybe perhaps somewhere here, right? And then you're going to end up getting some type of error or warning message because you're rewriting the same include a number of times. So having the header file prevents you from running into that situation. Did that make any sense? Hopefully. So you're saying if you include, will it force a recompilation? What do you mean by recompilation? Could you be more specific? No problem. Take your time. So while you're writing, I'm going to just go ahead and do void foo. And let's just say that I'm going to delete this and do maybe... So what I see what you mean, but it would not, it will create an error, yes. That depends on the compiler that you're using, but most likely it will create an error, but it won't be due to the fact that you're having multiple includes as part of your source file, but rather the reason being is you're having multiple definitions for the same function. So let me just make maybe the example a little bit more clear, is look at it this way. So we have this function prototype or just the function signature that lives within the .h file, right? And now we have the definition of this function, but it's living exactly where? In the implementation. So what happens when you include this header file? Well, every single file, right, that has access to the header file will only ever see the function prototype. Correct? And that's perfectly fine, because what happened is you're copying this function prototype, for example, here, like you're linking that with this file. Then since this file is including this other one, then this function prototype will also be linked through this file. And then finally, because this one includes this one here, then this one will also be linked to the client code. You see what I mean by that? right? So what happens when you include only the .cpp file? And let me just erase this one for now. So what happens is, if you were to include the .cpp file, notice that this body of the function will be included here, right? Then what happens when this guy includes this one here? Then this body of the function will be redefined for this particular file, right? So now you have a collision between this function that was defined here, and then we have another definition for the function that was defined right here also, right? And finally, when you include this file in your client code, then you're going to have three definitions for the same function, right? And it gets even worse when, for example, it gets even complicated and more tedious when you have an include, right? And let's just say that this include grabs stuff from this file, and that this include grabs stuff from this other file here, right? So the pattern here is a bit confusing because this more or less looks like a triangle now, right? Where you have this guy is borrowing things from this guy as well as this guy, and this guy is borrowing things just from this one. So if you were to do the .cpp file, you will have multiple definitions for the same function, whereas using a header file is no problem. You could have something as crazy as a triangle here, as having this kind of triangle relationship, right? But it doesn't matter much because you will have things linked to the same prototype. And by the time you make an invocation to the function foo, all we need to do is, where was foo defined? Well, it was defined inside the .cpp file, which means that we have only one definition for multiple instances of the same function prototype. Okay, so it's much, much easier. Yes. 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 You can think about the prototypes of the middleman responsible for linking things to the function definition. So you can actually just call every single time you use a function prototype. All you do is, where was this function defined? So I can make an invocation to the function regardless of how many times it have been linked, right? So is that actually somewhat clear? Awesome, no problem. So yeah, so the reason what I was talking about this is because in terms of Java, things are much different, right? The way in which you include things, and typically what you do is, if you want to do some includes, what you do is you create packages. Not necessarily, but typically you will do that. It depends on the hierarchy. For example, if you were to do, in that case, all I have is the source file. So for example, let me see if I want to do, let me just create another file here, and let me call it, I don't know, let me call it blah, right? So I'm gonna call this blah, and now what I'm gonna do is, now let me erase this for now, since I don't need it. So let me erase that. And here, let me just go and create a public static variable, public static int 1, and let's assign the number 1 to it, which is lane, but that's a very basic example. We could do public static void foo, and then let's see if we could just go ahead and do main. And notice now, right? That's the nice thing about the IDE, because you have easy access to things that are specified, or in this case declared in other source files, right? So notice that the way we do it is, let's just say that I want to use this fun here, or I could actually just call the print function, and I do ben here, right? Notice the difference here is that I didn't have to include anything explicitly. The reason for that is, we are on the same level within the hierarchy of our project, right? Or in our project. Meaning that the main and the blah file, they both reside within the same directory or folder. Which means that because they both live on the same directory, each file can have access to each other's fields, so long as they are declared public, right? So they could do that. Correct. Now, if I were to create, for instance, a package now, and I do, I don't know, let's call it lame, right? And then inside the lame package, I do, for example, new class, and I do test. Now notice I'm specifying exactly the directory in which the file was declared or can be found, and I could do another public static void bar. And if I want to access, let me see if I can access anything from main. Oh, that's something else that is trying to access. That println from bar. And if I go back to main here, I want to do, for example, it's called test. Let the bar. So notice now, if I wanted to use the static function called bar from within the body of the class test in my main file or source program, then I have to explicitly import the package in order to access the field that I want to access or call from the test class, or excuse me, file, right? So I could do that, or I could say, you know what, I don't care, and just give me everything that was declared or that can be found inside the lame package or directory, right? And so that's one of the main reasons. And the reason why I like to point this out is because unlike in C++, where you have to specify explicitly the way in which you want things to be compiled, in Java they do it in a much more elegant way, because now you have a structure that actually defines the sequence in which everything gets linked, or if you like to use the terminology that they use in C or C++, assemble, right? So it's much better, and you can think of packages in a way as namespaces, which is something that you will have in C++, right? The reason for using namespaces is so you can avoid having or over polluting, so to speak, your program with random names, right? And typically what you do is when you declare a namespace is because you want to specify things that may be related to each other. And by things I'm talking about, it could be just global variables, or it could be functions. For instance, if you have a namespace that is called math, right? For example, you want to define, maybe you want to have a global variable for pi that people can use, or some functions that will do any type of mathematical computation, right? But everything will be within the namespace itself. In case of Java, what you could do is I could easily just create a package here and call it, I don't know, math, for example. And here I could create multiple classes for different type of mathematical problems. For example, to do some type of, geometric computation, I could create a class called geometry. I could create another class called trigonometry, and so forth. And all I need to do is just import the math package, and everything that was declared within the math package, and just do, for example, geometry, and then call some function here, and pass some arguments to it to do some mathematical computation and so forth, right? So you avoid that type of collision, or what we like to call name collision, between things that may be related in some ways but not in others. Okay, is that somewhat clear, hopefully? Alright, so now what we're going to do is do a simple class here. So what I'm going to do is I'm going to define a class within a class itself. Right? So I'm going to do public class, and let me call it A. And then here I'm going to do public int num for 1. Or I could do, actually, let me just do something much more meaningful. And do private string. I'm going to do n for name. Then I'm going to do private string L for last name, and then private int A for age. Okay. Then what I'm going to do is I'm going to have a public constructor here called person, that what it will do, it will take some arguments, and we're going to use those arguments to initialize these fields with some data. Okay, so we have, for example, string n, string l, and then in a, right? So n is equal to n, l is equal to l, and then a is equal to a. And then what we're going to do is we're going to have a function called print. Okay, and what we'll do is, we're going to do void. And what we're going to do is we're going to call the system.out, or the output device, the output string device or mechanism, to print all the values that each of these fields contain. So name plus n, last name plus l, and let's see, we do that, we do this, and then we're gonna do plus h, right, and then we're gonna do plus a. Okay, so let's see, what is he complaining now? Oh, I know why. Oops, I made a boo-boo here. So now what we're gonna do is in the main function, I'm gonna call the person class. Person p equals new person. Let's see if that works. Now, so obviously it's complaining because the the constructor that I specified takes 3 arguments. So I'm gonna do then, I'm gonna do Cisneros, and then I'm gonna do I'm old, so I'm gonna do 100 years old. Okay, and let's see now why we're getting these. Yes, so now we're getting that error. Well, if I do this, let's see, cool, yeah. So I was hoping that, okay, so I'm gonna remove this and I'm gonna just show you why. So now that the IDE is done doing the static analysis, is complaining and is giving me this squiggly line right here, right? And the message that is saying, it says it cannot be referenced from a static context. And the static context is the fact that we're using basically what exactly we're using the static function here to access that, right? So let me see if I can actually do the following. Instead of doing that print string, let me just comment this out. Actually, I could just make this the main function and just do that so I can run the program. So it's complaining, correct? And the reason why it's complaining is, I think you guys have done this back in 202. Hopefully, I don't know whoever you took it with, but maybe you went over this. And just another thing about the cool features that you take, that most of us take for granted when we program. Look at these little things here that you see before the word Ben or the last name Cisneros or the number, right? You see the N, the colon, L, colon, little a, and then the colon, and each of these basically represent the location or the position for every single one of the arguments that the constructor takes. So that's really nice, because that in a way is like documented, I guess. But anyways, so the reason why it says this is because we have a class that lives within another class, right? And this is not too bad, because if you think about the way in which the main function is executed, at least in Java, remember I said that you have to make your main function static, otherwise you will need to create an instance of the object or the wrapper class in this case, right, where the main is defined. So in this case, this class, in order for us to be able to access this class, we will have to create an object of type main. Right? That's the reason why it's saying here that we can reference a type person, because it doesn't exist within the context of a static function. The only way for us to do that is if we do something like, for instance, new main, something like this, and then look at that. If we see that this is person, right? If we do something like this, for example, and let's see if I do and obviously we have this, but more or less you get the idea, right? So the whole point is, instead of doing that, what I end up doing instead is says, okay, make the class just static, meaning that the class being defined within another class can be accessed anywhere, much like any other static field that you can think about, right? So we have this, and if I were to build it, now why is complaining? Oh, Java math package doesn't exist. Let me just delete that. Let me just build it again. Oh, yes, sure. I delete the function. Let me build it one more time. Now what it says, oh, it finished. Okay, cool. So if I were to run it, let's see. Okay, it says it finished with exit code 0, which means everything went okay. Now I could actually call the print function, and hopefully I will see the values as that I pass to the constructor. So let me build it one more time, and then let me run it, and look how I'm passing these arguments to the constructor, and yet what I'm getting in return is just null, null, and 0. Before I ask the question, one thing that I want you guys to remember, which is a lot different to what you do in C++, is that unlike in C++, every field that you declare in Java gets a default value always. Okay, for example, notice that we have three fields here, N, L, and A, and they have not been initialized, which means that the default value for any reference type, meaning an object, is null. And for primitive data types such as an integer, that will be 0, a float, that will be also 0.0, a double will be 0.0, a boolean, the default value, if it is not initialized, will be false, and so forth. Okay, in C++ is different. In C++, you are responsible for initializing your variables, otherwise you will get some rubbish, right? And you don't want to deal with that stuff anyways. So yeah, so question for you guys. Why do you think I'm getting these uninitialized values, even though I'm passing these arguments to the constructor of the class person? And here is the constructor right here. What do you guys think? um, now that you're saying that, you reminded me of someone that says, when in doubt, if you're working in Java, just say, is it because it's a class? That's 60% of the time that will work. 40% of the time, it may not work always, but could you care to elaborate or explain more what you mean? Anyone else, feel free to say why or to explain why you think that even though I'm passing some arguments to the constructor, my fields are not being initialized. Oh, go. Okay. That's true, but not necessarily, because I said before that if you don't initialize anything in Java, meaning explicitly, what happens is all the variables that you declare will have some default value. Aha, yes, that's exactly what I was looking for. So what happens is, and this is something that we're going to learn eventually, so don't worry too much about it. We'll learn more about it later on. This has to do with the scoping rules of just about any language, right? And obviously the scoping rules for some languages are different than others, but in most cases they are somewhat similar. So what happens is here is, notice that the arguments that or the list of arguments that are part of the constructor declaration here, their names of each of the variables are exactly the same as the names that we have here, correct? So what we're doing instead is that we are reassigning the same values that we're passing to the constructor to the same variables every single time, which means that we are not using any of the fields that we declare as part of the class. Okay, so one way to solve this problem is if obviously we change the name of these arguments. For example, N1, L1, and A1, very convenient, of course, very meaningful. It says a lot. So we do something like that, and so notice that before, the way I had it, look at it this way, and this is nice too, because the IDE, I don't know if you guys can see this, but the IDE is in a way giving me a hint saying that the value of n is never used, because what I'm doing, I'm reassigning the value to itself. And notice the coloring here, right? Now, if I were to change these guys to N1 and then L1 and A1, notice now that the color has changed completely, because now I'm using the legal name for this field, meaning that now I have a way to reference the fields of the class, right? Hold on, I will get back to you. So let me just build it, and let me run it out, and let's see what happens. And now I'm getting the correct output. Okay, what do you mean by but that would work properly in C++? Am I right? What exactly would work properly in C++? As for, would you mind telling me? And as for the other student who says that Java uses the keyword this, so there is another way to fix this. So let's just go back to the same thing that we had before, and notice that now we have the same issue. If I were to build it and then I compile it, cancel. So what I'm getting is, undefined behavior. Well, not undefined behavior, but rather I'm getting some the output of some fields whose values are basically nothing, meaning that they have never been used, right? So what I could do is to make the distinction is doing this pointer, right, this and this. Whereas in C++ you will do something like this, no pun intended. Then you do something like that, and then you do something like this, right? And then if I were to build it, and if I were to run it, then I get the same thing as well. Okay? So it really, now, this really depends on, no problem. So this really depends on what you want to do. Now, some people ask, is there a reason as to why you will use this pointer? Yes, exactly. That basically depends on personal preference. But in reality, some people will ask me, like, is there any advantage of doing this versus doing it differently? And it really boils down to the level of laziness that is imprinted within your DNA, right? Meaning is that, do you really want to use different names for your variables? If you want to reuse the same names, but you want to make the distinction of what is a field and what is just a variable, so the compiler knows exactly which fields you are using as opposed to which variables you're referencing to, then you have to use this pointer. Okay, and so it becomes down to preference. That is really not, in reality, even if I were to, even if I were to do something like this, for example, so let me just do and put it actually M1, L1, A1, and can I do these? Let's see. Oh, I can. Great. So something like that. So what happens is that, notice that now we know exactly what N1 is, because the value of N1 goes to, or actually, excuse me, the value for M1 will be the value that we pass to the constructor, because we have the same name that can be used to reference this argument, right? And this n clearly and surely is the one for the field. But the translation of what happens behind, it resolves to something like this, where it says this n1. So whether you add the this pointer or not, it doesn't really matter. By the time you generate some bytecode, it will be more or less represented using the this pointer, okay? For C++, the same behavior happens. Whether you like using a this pointer or not, the compiler still is gonna put it in there for you, whether you like it or not. So yeah, so that's more or less preference from, I guess, the programmer point of view. All right. So we have that, and so what happens is this, and I'm gonna show you the following. This is something that we're going to go over more in detail, and this is why I truly hope that by the time you guys get to phase 4, I truly hope that the thing that you guys will get out of this is to get an idea of how object-oriented programming is made possible, right? Of all the invocations that you do, of all the functions that you overload, right? How the in this case the runtime system knows exactly what function to call based on the object that you are using to make the invocation. Typically, people will say, well, you know what? What happens is a runtime, it knows exactly the type of the object, then it looks at the class, and then it goes and it finds the function that is associated to the class, and then the invocation takes place, which is true, but you don't know exactly the internal implementation of how all of that is made possible. So hopefully, by the time you guys get to phase 4, once again, when you start working on phase 1, phase 2, all the things that you do on phase 1, phase 2, and phase 3, they all lead to phase 4, which means that by the time you get to object-oriented programming, then you will know how things work underneath the hood. So hopefully you guys get that and out of this class. At least that's the one thing that I want you guys to somehow understand, or at least improve your understanding in terms of object-oriented languages. Okay, any questions? Let's see. Maybe not. All right. I guess no questions at all. So yeah, so let's just do that. Now, in case of inheritance, for example, what we could do is I could just easily go and say, okay, let me just create a class here. Call it, I don't know, let's do public, do the static as well, and call it a student, right? And I forgot, public static class. And now what I'm gonna do is a student has an ID, so I'm gonna do private int ID. Right? It also has a name, a last name, as well as an age. So what I'm going to do is I'm going to reuse what I have before and just implement the properties of the person class as well as the fields. Let's see what happens. It's not a default constructor in the main person. I cannot do the extends. Maybe if I do that, will that work? Why is that doing? There is no default constructor available in main.person. Oh, okay. Finally, yes. Don't worry. I know what is actually happening. So I have that. I'm going to extend. So in case of C++, as you were wondering, in C++ you will normally have a student, and then you will do that, and then say person, right? And then you have your class definition or the body of your class, right? And you could do here, I think, if I'm not mistaken, you could do public or protected or private, depending on the type of inheritance that you want to do. Obviously, every single access modifier will change the way in which the fields of your parent class can be accessed. So now what I'm going to do is create a public class, public student, and then take a name, a last name, an age, and then an ID. Okay, and what I'm gonna do is I'm gonna call super, and then I'm gonna pass the name, the last name, and then the age. And then what I'm gonna do now is I'm gonna use this pointer to make the distinction very clear between what's a field of the class and what's a variable that belongs to the constructor, and just do the following. Now, this is the keyword super is what allows the super constructor of your parent class to be called. Obviously, the way in which you're going to initialize the fields of an object that inherit some member fields or some properties or some accessors and getters from another class is by using the super always first. Okay. The reason for that is it goes back to the things that you want to initialize first, right? You don't want to initialize ID first and then make the invocation to the parent class to reinitialize what you have already previously initialized before. So now you have this. So normally in C++, the way you will do this, you will just use, for example, the name of the class, right? And you will use, I think you will use the scope resolution operator, and then you will do this, and then you will do L, N, L, and then A. Let's see, it says, what happens when you pass the current class? If I'm understanding this correctly, if you're that will depend on the name of the argument. You could pass basically just about anything to any function, and you will have no problems whatsoever. The only time that you will have to use a this pointer is if it just so happens that the argument that you're using in the function has the same name as one of the fields of the class. In that case, then you will have to use the this pointer, right? So, for example, if I have something like I guess I'm gonna do this silly thing here, public, for example, and I do print public static, and I do print ID, and I do int ID. I have to do void, something like that, and then I do system.out that println, and I use ID. Surely the ID that I'm referring to is the closest one to the function, meaning the argument, right? Now, if I wanted to use this ID, what's going to happen now? You may be thinking, well, can I use this pointer? Okay, let's see what happens. If I use this and I do that, notice that now it's giving me an error, because the way in which we are accessing this ID, which is the field of the class student, we're accessing that through an static function, or in this case, a static context, right? And it goes back to the whole idea of the only things that you can access within a static context, meaning being a static function, are things that are static. If you want to access the fields of a class through an static context, then what you need to do is you need to create an object, right? So what we could do is say, okay, just pass the pass the student, correct? And just for giggles now, I will have to just make this public, and then I will do SID, and that works perfectly fine, even though the context of this function is static. The reason for that is ID being a field that can only be accessed through an object. We are doing exactly just that. We are accessing this field through an instance of an object student. Okay. Okay, cool. No problem. So now we have this, and what I can do now is, this is the nice thing about, I could do two things. I could go ahead and say, okay, so let me just create a print function do public print on the return type print, and let me just print what a student is, and let me just make this private, right? So let me just make this private. So what I could do is I could do system.out.println and said okay name, and I could do, for example, n. But notice now that it's giving me an error, right? I'm trying to access this field, but it's giving me an error. The reason for that is I'm trying to access a field whose access modifier is private. So I have two choices. I could make that public or protected. If I make it public, everybody can access it. But if I make it protected, then only things that inherit from the class in which the field was declared can access it. So it seems more reasonable to make this whole thing protected, right? That, and including this one, and now look at this. Now I don't have any errors whatsoever. So I could do the following. I could just go ahead and copy and paste this, and paste it here, right? And then just add the last thing to it, which is the ID, right? But that's just redundant because what I'm doing, I'm copying and pasting the same thing multiple times. But what I can do now instead is I could overload the function. And what I do is the following. I could just go ahead and say, you know what, I'm too lazy, which most programmers are, by the way. And what I'm going to do is I'm going to just reuse what I have from my parent class and just call it. So I'm going to do super.print, and there you go, right? So if I were to create a student object, for example, a student s equal new student, and I could just copy all this, and then I could do 1, 2, 3, 4, 5 to that, and then I could change this to s, and if I build it, okay, no errors, that's good. And if I run it, there you go. Look at that, right? And this is what we call as overloading a function. Okay, we're overloading a function, meaning in the way you will do that in C++ is very simple, because in C++ you will just use the name of the class, then you will use the function, and then you will just call it right away, right? So notice that this is, here we have to do person.person. So this is what we call the scope resolution operator, because in C++ basically what you're saying is when you compile your program, you're telling the compiler, okay, so I have a scope resolution operator, which means that I have to have two things on each side. On the right hand side, I have to have a function name or some name, because it could be a field, and on the left hand side I should have the location where I can go and find the name of the thing that I'm trying to access, right? So in this case, when in C++ you're using G++, what you do is you're trying to access the print function. You tell the compiler, okay, so find this print function inside the person class. This is what that scope resolution operator tells the compiler to do. And that's exactly what the compiler will do. It will go to the person class in C++ and look for the print function. If the print function is called, then no problem. Can be found, then no problem. You will be able to compile your program, obviously. You will generate the correct set of instructions to make the invocation to the print function when you run your program, and life is good. If that doesn't happen, then you will get an error, a compile time. In Java, it's much easier, because this super says, okay, which class do I inherit things from? Okay, let me look, extends person. Okay, perfect. Which means that this print function has to be inside this person class. Let's look at it, and there it is. And there you go, right? And so that's exactly what happens, and no errors whatsoever. So this is what we call function overloading as opposed to function overriding. Okay, so you have different things to do, and this is the reason. One of the reasons why multiple inheritance is not allowed in Java is because we don't have the scope resolution operator like you do in C++, right? Imagine if we allow for multiple inheritance, and then we said something like, for example, semicolon human. Assuming that there is a class called human, for example, right? And we're doing multiple inheritance, which is something that you can do in C++. And then the only thing that we can do to make calls to functions that we inherit is by using the super keyword. So let's just assume for now that you have the print function defined in both classes. Notice that how do we know exactly that the print function that we're using comes from the human class and not from the person class? We don't. And that's what creates ambiguity. So we end up having some errors, right? If we were to have the scope resolution operator, no big deal, because all we will do is just specify the name of the class, from which we want the function to be called from, and there you go, that's fine. Because now we explicitly make it clear to the compiler, look, I'm calling the print function from the human class and not from the person class, so go ahead and make that invocation instead, right? So that's the reason why in Java we don't have that ability. We do stuff like that through what we call interfaces, and that's something that I will talk about probably some other time. Now, since we're doing something that is very quickly, and then I will let you guys go. I know some of you guys probably have other things to do. So now, in Java, for example, we have something that is called object, right? And then we have, actually right now we have a person class. And then we have something that is called a student class. Right. So what I'm saying is this is what we call, well, right now what we're doing is we're inheriting properties from person, and then person inherits things from object. So the nice thing about Java is that every class that you declare will always inherit stuff from object, always. So I could create, for example, a class called animal, right? And what's going to happen, the animal class will inherit things from the object class. I could create another class called, I don't know, cars. And the cars class will always inherit things from object, right? So every class that you declare in Java will always inherit things from this object class, always. And there are reasons for that. But in terms of the type of inheritance that you can do in Java is what we call multi-level inheritance. The reason why it's called multi-level inheritance is because there are multiple levels, right, from which you can have a parent class. Correct? We could have another class here that we could call it whatever, and we can inherit things from the student class, right? So we have this hierarchy of inheritance that happens in Java, okay? Which means that, notice the way I do the arrows, right? Which means that a variable of type person can hold a reference to a student object, and so forth. And I'm going to show you this, and this is something that you do in C++ as well. That's what allows the whole, this is actually, let me see. This is, at least in C++, this is what makes it possible, the whole idea of having virtual functions. I'm pretty sure you guys use virtual functions at some point in C++. For example, I could use P and assign the student object that I created. And then I could use P to call the print function, right? So now the question is, which print function will it call? The one from the parent or the one from the student? What do you guys think? Okay, we have a parent. Okay, anyone else? For those who are watching. A student, damn, okay, damn. A student in final answer, you're saying, okay, just remember your answer is final. You just said it, so no backseas. All right, so I'm gonna just build this, and then so it built successfully, which means that the program will always run. And let's just compile it. Yes, and you were right. It will call the one from the student, right? Correct. Now you understand the why, but when we get to phase 4, you will see why that's possible and why that happens and how that happens actually, right? But for those who are wondering, it's actually very simple. What happens is if we were to look at the iPad, so we have the person here, and we assign exactly a student object, right, which we created before. So what happens when we do p.print? It's actually very, very simple. By the time we execute this line of code, what happens is we check at the type of the type of this reference variable, right? We check for the type of this guy, and notice that the type that we specify, even though it is a person class, what happens is we go and look at whatever was assigned to it, correct? So what is the type of this object that we assign to this reference variable? Well, the type is student. So by the time we make the invocation to print, rather than going to the person class instead, based on the type that we use during runtime, meaning when your program executed, we're going to instead call the function from the student class. Okay, so that's more or less what happens, and that's what allows the whole idea of virtual functions in C++. So hopefully you guys learned that when you took 202, and I will stop right here and let you guys go. That's basically all that I want to cover, since it's more or less somewhat similar in terms of C++. Next week I will go over enums and as well as interfaces, and I guess that will be basically everything you will need to use, at least for the EVM project, as well as for the compiler class, if you're watching. But yes, so any questions before I let you guys go? Any questions at all? All right, well, no questions, so okay, I'll let you guys go. Have a wonderful rest of the weekend, a very long weekend. No problem. I'm glad that you did. No problem. So have a nice weekend, guys, a long weekend, and later tonight I will do the whole phase 1 thingy. Then don't worry, I will send out like an email so everybody knows, and I will also let everybody know about the lecture for phase 1 on Discord. So have a good rest of the weekend, a very long one for sure. I will take advantage of that. I'm telling you this right now. Anyways, I will see you guys. Have a wonderful rest of the day.